So here, these are all the global variables that I use in my program. So difficulty is set to 0 to show that difficulty hasn't been selected before the game has started. Difficulty speed is a dictionary which I use to determine the speed of the enemy. So here it's in ticks. Uh, the difficulty corresponds to this number. So 1 is easy difficulty, 2 is medium, 3 is hard. Um, so this number is in ticks, and it represents the delay between enemy moves. So on easy mode it's 800 ticks, on medium 600, on hard it's 450, which means that on harder difficulties the enemy will move faster. Difficulty, remembers, is a dictionary as well, and it's used to for an enemy memory. So here on easy, this is in ticks as well. So here in easy mode, the amount of time the enemy remembers your location for is 3000 ticks, so 3 seconds. On medium mode it's 5 seconds, on hard is 6 seconds. This is the screen width, screen height, and this is set to none to show that like the game hasn't been won or lost yet. Um, so border is basically size of one tile, and I use it to offset the maze by one tile to like right and bottom, because I also use I have indicators on each side of the screen. So I use border and maze width in order to and maze height in order to like offset the maze, so that I can fit the indicators on each side of the screen. So here I initialize spy game. I create a display using these global variables here. So screen width, screen height. Here I also start a clock in ticks. I choose a font and I set run to true. So this is the first class of my program, the button class. Here I initialize all the variables. So we have self, obviously, then we have x, y, which are the coordinates of the top left corner of the button, then width, height, text, color, which is the color of the button by default, then we have text color, and chosen color, which is the color of the button when you press on it, so it changes color when you press on it. So here then we have draw method, in which it draws a rectangle on surface, which is the display. So it's disp. And then you also have clicked method, which uses the position of the mouse to determine whether the position of the mouse is on the rect of the button. So whether it glides, whether the mouse is on the button when the mouse is pressed. So now we have the class style. Here again I initialize it, self, coordinate, size, and then these are boolean values I use for determining whether there is a wall in that direction. So if a tile object has a wall to the left, so that will mean that left will equal true, and if there is no wall to the right, then right will be false. So then we have the color, this, and then we have the draw method. So here it draws the inside of a tile, and here so it checks whether each of those directions is true. So for example, if up is true, that means there's a wall up So it will draw a line here. So on display, it will draw a black line from top left to top right, because the wall is on top of a tile. If there is a wall, for example, to the right of a tile, then it will draw a wall from top right to bottom right, and this is the thickness of the wall that it's drawing, which is 1 pixel. Now we have moving entity class. So this class I use for the player and the enemy using inheritance. Here I have speed for the player, which is 200 is in ticks, is a delay between the moves that the player can take. So this is made in order to prevent the player from being able to move really fast in the maze. So there's a delay. You can only move once per 0.200 seconds, 0.2 seconds. Here we also have last move time, which is in ticks as well. I use this to keep track of when was the last move made. Again, in order to count 200 ticks and then to allow the player to make another move. That's why it's used. And then I have self-rect here. I use rect to this is to translate the coordinates from the grid, so like tiles in the grid, to pixel coordinates, because Pygame uses pixel coordinates to draw stuff. So here we also have move method. So what's actually happening here is we subtract current time, which is the time in ticks of at that point in the game, from last move made. So here this is last move, and again it remembers the last time a move was made. So if this subtracted from this is less than 200, then you can't move. Otherwise you can. And here just compare. So if you get a direction up, for example, to move up, then it will see whether the tile property up right here, it'll see whether it's true, and if not, then it will move up. Otherwise it won't move. So we also have this here. It updates the tile, it moves, draws the tile like in the new position, and it also updates last move to current time, because obviously that's the the last time a move happened was just now. Okay, here we also have player class, which inherits from moving entity, it initializes, and yeah, and then we have move method, which inherits from the moving entity class. So it just stores whether the move was successful or not, and if the move was successful and it returns true, then it will increase the move count. I did this to keep everything encapsulated. Now we have enemy, which inherits the moving moving entity class. So here path none. Path is the what I use in A star, basically to get a path for the enemy to follow. Then path index, meaning on which stage of following the path the enemy is. Here it's 0, obviously, because the path hasn't been generated yet. than the goal. And self saw is in ticks. Um, it remembers the last time the enemy saw the player, and then remembers is how long the the enemy remembers the player for. So here is 5,000. So 5,000 ticks. So 5 seconds. Um, Last known position. Again, this is to remember the last position at which the player was seen. This is none because it just started. Um, yeah, so normal speed is speed. Um, yeah, and here if difficulty is medium, then here I just calculate basically how much faster the enemy is when it sees a player. It's different on every um, difficulty. Now this is sees enemy method for the AI. Um, so in direction, it just checks for every direction. In each direction, it sees whether there's a wall that way, and if there is, then it just breaks. And then here it checks for boundaries, whether it's within the boundaries, and basically it just scans in each direction to see whether there's a player there, and if not, it returns false. Chase player, um, chase player method. So here it just calls this sees player to know whether there is a player in the line of sight. Um, so if there is, then it records the time when it saw the enemy, and if the difficulty is medium, then it just calculates how far the player is without accounting for walls. So it uses Manhattan distance basically to figure out the same calculation I use in A star. It uses this to figure out how far away the enemy is, um, and yeah, basically if it's less than two less than or is 2 tiles, then it knows where the player is. And then if it's not medium, if it's easy or hard, it can only know where the player is if it either sees it in its direct line of sight, or if current time minus self saw it's less than the remember, so less than the value that like in ticks that allows the enemy to know where you are for some amount of time. Um, so yeah, here if gx, so if x of goal is not none, so if it has a goal, then it changes its speed to chase speed, calculated above where I showed it, and basically it just starts following the player. It gets a path using a star, calls a star function, and yeah, it sets the path index to 1, which means that is the first it will start going from the first index of the path that a star returns. Yeah, so now if the enemy sees the player, deletes any path that it already had because it doesn't need it anymore, it's gonna chase the player instead. And here it calculates which gap is bigger. So it's gonna be either vertical or horizontal one, and if the vertical gap is whichever one is bigger is gonna go that way. So if horizontal gap is bigger, it's gonna move horizontally, and if it's vertical, then vertically. Else, if So if the player isn't seen, if it doesn't have or if it doesn't have any path, yeah, then it's just gonna randomly select a goal, and it's gonna call a star to find a path to that goal, and it's just gonna randomly move. Now here we have a priority queue used for the A star algorithm pathfinding. So here I get a queue first, which is just a list. Then I define in queue. Yeah, so how it enqueues. Here's a bubble sort. Because this is a priority queue, the tuple with the smallest value should be at the front. This is for a star algorithm, and this bubble sort algorithm just um, makes sure that, you know, every single time the value with the least the smallest f value is going to be at the start of the queue. And then we have dq operation here, and is empty, just to check whether the queue is empty or not. This is the a star function, so this stores every neighbor to be explored. This stores the starting tile, so this is 0 because this is the f cost, and it doesn't cost anything to get to the starting tile. Explored, so this is a set that stores every tile that's already been explored, came from, stores pointers to like previous tiles so that you can reconstruct the path back when you finish pathfinding. G cost stores the G cost of each tile, which is the cost from the starting tile to get to that tile. So the every next tile will have the G cost that's one more, because obviously that's the next tile. Okay, so then it sets the G cost of this starting tile to 0, and then the main A star function starts. So basically here what's happening is that the tile with the least F value gets dequeued, and then if it's the goal, the tile that was just dequeued, if that's the goal tile, then it just reconstructs it. It calls this get path, and it just reconstructs a path back. It's here, and if not, then it adds it to the explore tiles. Then it calculates neighbors for that tile if there are no walls between them. Yeah, so if each of those neighbors, so for each of these neighbors that it calculates, if the neighbor isn't explored, then it just skips it, and then if it isn't, it calculates the coordinates. The tile coordinates for that neighbor. Then it calculates the G cost, F value, and heuristics for it, and it just enqueues it into the priority queue, and then it all starts again. Here we have class walls, which should actually be called indicators, because they're indicators, not walls. And here I have colors, so that's when the enemy is one tile away from the player. That's when it's 2, 3, 4. It decreases by 50, so the red decreases by 50. Yeah, so here, as we can see, the color, if the distance, yeah, so it just selects the color from here based on distance. Yeah, and then it draws it. So yeah, and it just draws every single one of them for 4 walls. Here's class exit, and it just calculates how far the exit is. So here in chances, it calculates the chance for the exit to be close, for it to be like not that far away, and then for it to be far. So as we can see, there's 20% chance that the exit will be close, 40% no, 20 20% chance for it to be like in the middle, midway, and then yeah, so it's 60% for the exit to be far. uh, then we have create exit method, so it has 2000 tries to create an exit, and so how far it calls this thing, and then it calculates the minimum and maximum distances for the exit to exist. Yeah, so here it tries to um, generate a maze so that it's within the minimum and maximum distance, and then it calculates using the Manhattan distance. Yeah, so this class visibilities is where the visibility system comes from, and how it's controlled. So basically what this does is just so bends is 2. So basically what this entire thing does is it goes in all 4 directions, and it adds the tiles that it can see that are in the direct line of sight into the list, and then here it calculates so where the bends to where the maze bends, it will go like in the bend 2 tiles, and it will add that to the list as well. And then a bit down here somewhere I draw only every tile that's inside that list. Now here I just create buttons, the difficulty buttons, the state main menu. So here I fill the display, I draw the buttons, then I check whether they're being pressed, and if they are, the difficulty changes. Yeah, then it also changes color if it's pressed. Yeah, so it prevents you from clicking the button if a difficulty isn't selected. Yeah. So here we have the main Wilson's algorithm. What this does is, so there are 2 lists. There's a buffer list and there's part of maze. So what this does is it chooses a random tile first, called a home tile, and it starts a walk from that home tile, a random walk in 4 directions, and as it walks, it adds every tile that it steps on into the buffer list. Yeah, so here it chooses a direction. 1 is left, 2 is up, 3 is right, and 4 is up. No, down, down. Yeah, and it just adds it to the buffer list, and then if it happens that a tile is already in the buffer list, and it just happens to step on it again, then it will like cut off that loop created in the buffer list, and it'll just keep walking. So yeah, it just yeah, and then when it oh yeah, it also chooses a random tile before all this, and it adds it to the part of maze. Um, part of maze. Where is it? Yeah, so it chooses a random tile, uh, yeah, starting tile, and it appends it into the part of a maze so that when the walk is happening, it'll always check whether the um, it has reached any tile that's in part of a maze. So if a walk is happening and it reaches um, this starting tile that's in part of maze, then it will like backtrack, not backtrack, but every single tile that's in the list. Where is it? Yeah, so here, when it reaches the tile that's in part of maze, it will start adding everything that's in buffer list into the uh, part of maze list, actually adding it to the maze. So yeah, now here we have uh, the enemy initiate, like creating the player, creating the enemy. These are the um, coordinates generation for them. Uh, yeah, then we set the speed for enemy. I create wolves exit. Um, yeah, yeah. I also create a timer. Here I just check for button presses for when the buttons are pressed. So that's the player movement. Uh, yeah, and then here I just draw everything that's invisible. That's in the list. Uh, yeah. So everything that's in the list, everything the player can see. Everything else isn't. It doesn't get drawn. And yeah. So this is the and the game menu, which gets triggered when the player loses or wins. Uh, yeah, so here are just the buttons created at the end. That's the gap between the buttons, and I just increase the gap where I need to. So, or I rather decrease the gap. No, I increase the gap as well sometimes. Anyway, yeah, here I also increase the X value, like how yeah, yeah, and then here I just make buttons. These are actually aren't these aren't buttons, but I just like you can't click them, you can't use them, uh, but yeah, I just made them buttons because it's easier. And then here is the storage system. So basically, I just store everything in a document.